So hi everyone, good evening and welcome to this live session hosted by TalentSprint. As you all know, today we are going to be doing a session on relative speed from the topic of time, speed and distance. So this is Gayatri here and I see that a lot of you have joined the session. So hi Rami, hi Raj Yadav, hi Ashutosh, welcome to the session. So let's wait for a few more students to join before we start. Okay, so let's start today's session. So as I said, we are going to be discussing relative speed from time, speed and distance. So before going to relative speed, first let us look at a few basics of time, speed and distance that all of us should know before we solve any question that comes from this topic. Okay, now the very first thing, okay, Sachin says hi, hi Sachin. So the very first thing that you should know when it comes to time, speed and distance is the relationship between distance, speed and time. Okay. See, we all know that distance is equal to speed into time, right? Or I can say that speed is equal to distance by time, or again time is equal to distance by speed. So this is the basic or fundamental thing that you should know about time, speed and distance. Now, next thing that we should know is the conversion, right? See, when we solve questions on time, speed and distance, the first thing that we should look into is the units of the given given information, like units of time, speed and distance, right? All the units should be in the same standardized way. For example, if I say that distance is given in kilometers, the speed has to be in kilometers per hour, correct? And the time has to be in hours. Similarly, if the distance is given in meters, then the speed has to be in meters per second and the time has to be in seconds, right? This is one thing you should standardize before you go about solving the question, right? Or if it is given in miles, let's say if the distance is given in miles, then the speed has to be in miles per hour and the time has to be in hours, okay? So what is the basic conversion that you should know, right? See, distance and time, you will be able to convert it easily, right? How 1 kilometers is equal to how many meters? 1 kilometers. Hello, can't you hear me? Karan says he can't hear me. Can you guys hear me? Is there any issue with the voice? If any of you can respond, it will be good. Can you guys hear me? Is there any issue with the voice? Okay, I'm assuming you're able to hear me. See, if you can't hear me, please let me know. Karan, I think it's fine because all the other students are able to hear. No, is it? Yeah, Raj Radhav says yes. Okay, you guys can hear me? Good. Yeah, great. So Karan, it is some issue with your system. Please check. Others are able to hear. Great. Okay. So, okay, coming back to time, speed and distance. See, the first thing that we should know is the unit conversion. Okay. Now, let us first look at distance, right? What are the units of distance that you generally get? You either get units in terms of kilometers, right? Distance is either measured in terms of kilometers or meters in general in the questions that come from this topic, right? So what can I say? 1 kilometer is how many meters? 1 kilometer is nothing but 1000 meters. We know this, right? Similarly, when it comes to time, generally time is given in terms of hours or seconds, okay, in problems. So if it is hours, 1 hour is how much? 1 hour is 60 minutes. 60 minutes is how many seconds? 60 seconds, right? So I can say that 1 hour is 60 into 60 or 3600 seconds, right? So the basics, see, these things I needn't write it for you. You should be knowing all these things. I'm just recollecting, okay? So that's why I'm not writing anything on the board. It's just for us to recollect what we know already, okay? So the first thing you need to know is the kilometers to meters conversion, then hours to second conversion. Both of this is very easy to do. Now the next thing is speed. Now speed is generally either represented in terms of kilometers per hour or in terms of meters per second. So how do you convert this? right? Again, for that we know that 1 kilometer per hour is equal to 5 by 18 meters per second. Okay, remember this always, 1 kilometer per hour is equal to 5 by 18 meters per second. Similarly, 1 meters per second is equal to 18 by 5 kilometers per hour. So if you know these, then the questions will become very easy to solve. Okay, now if you are thorough with these basics and if you have a conceptual knowledge about this topic, solving questions from this topic becomes very, very easy, right? There are no formulas that are required to solve the question if you have knowledge about these. Okay, so let's go about solving questions from relative speed now. Okay, so before we discuss about what relative speed is, I would like to know from you all. Okay, can you guys tell me what is relative speed? Can any one of you define what relative speed is? I'm waiting for your answers. Yeah? Ravali, everybody else is able to hear me? Can anybody tell me what relative speed is? Difference between speed. Yes, Shubha Reddy says difference between speed. Right? Okay, calculating speed with two objects. Okay, correct. So, actually how do you define relative speed? See, when relative speed comes into picture when you are considering two or more objects. Right? Now, when there are two or more objects, the speed of one object with respect to the other is called the relative speed. Basically, you are comparing the speed of the two objects. Okay? So, now let me share my screen with you so that it will be easier for you to understand. I hope you guys can see my screen. Yes? So, as I said, relative speed is the speed of one object with respect to another when we are considering at least two objects, right? And generally from time, speed and distance, relative speed, we have two important applications of relative speed. One is the train problems and one is boats and streams, right? You can see that in a lot of recruitment drives, questions from trains and boats are very common. Okay, these are applications of relative speeds. So let us define relative speed and see what are the concepts that you should know to solve a question that comes from this topic. As I said, if you are aware of the concepts very clearly, there are no formulas or no shortcuts required to solve questions from this topic, right? If you have a good conceptual knowledge, you will be able to solve any question from this topic, right? You didn't refer any books, just understand the concept clearly, right? Okay, now let us see how it works. So, see, there are two cases, right? When you are taking two objects, right? Relative speed, as I said, is the speed of one object with respect to another, right? There can be two cases. What are the two cases? One is the case where both the objects are traveling in the same direction, okay? So, see here there are two objects. These two objects are traveling in the same direction. There are two cars. Both of them are traveling in the same direction, right? So let us assume that this car is traveling at x kilometers per hour and this car is traveling at y kilometers per hour. And now, or let us take numbers for easier understanding. Let us say that this car is traveling at 60 kilometers per hour. Okay, let y be 60. So I am saying that this car is traveling at 60 kilometers per hour and this car is traveling at 40 kilometers per hour. Okay. So now what is happening? After some time, the car which is traveling at a faster speed will overtake this car, correct? So what is the relative speed here? When we calculate the relative speed of two objects traveling in the same direction, we consider the net speed as the difference between the speed of the two objects. So here the relative speed is y minus x, correct? Or I can say it is 60 minus 40 or it is 20 kilometers per hour, correct? Similarly, now if there are two objects that are traveling in the opposite direction, let us say this is traveling at 60 kilometers per hour and this is traveling at 40 kilometers per hour. Now what is the relative speed? The relative speed is nothing but the sum of the speeds of the two objects, right? 60 plus 40 or that is equal to 100 kilometers per hour. right? Now, Chandu says, why don't you start company specific training on online? Chandu, see, we have done lot of sessions on company specific training. So you can refer to the videos that we have done, right? Okay, so I hope it is clear. Here, when objects are traveling in the same direction, the net speed or the relative speed is the difference between the speed of the two objects. And when the objects are traveling in the opposite direction, the net speed is the sum of the speeds of the two objects, right? I hope it is clear. Now, how do I, see this is, why am I saying this, right? Have you all, see, I am asking you a question, okay? We have all experienced the concept of relative speed in our lives, right? Can you tell me how you have experienced relative speed? See, for example, all of us would have traveled in a train, right? See, I am just explaining the whatever I have written here, no? I am just explaining that to you in a practical way, like how we have experienced this concept of relative speed in all our lives, okay? So, see, we have all traveled by the train, right? Now, for example, let us say that there are two trains, okay? Train 1 and train 2, okay. Now we are sitting in train 1, which is traveling at a speed of 40 kilometers per hour, and there is another train 2 which is traveling with a speed of 60 kilometers per hour, okay. Now this train 2 is overtaking our train and we are sitting in train 1. So when you look at train 2, what is it that you see? Do you feel that this train 2 is traveling at 60 kilometers per hour? No. We will not feel that the train 2 is traveling at 60 kilometers per hour. We will only feel that the second train is traveling at a speed of 20 kilometers per hour. And also, we will feel that we are stationary in train 1, right? We will feel that when we look at train 2, we feel train 2 is moving at a speed of 20 kilometers per hour and I am stationary looking at the train. That is what you feel. So why are we feeling this way? See, this is because relative speed is coming into the picture. I hope it's clear. Actually, we would be traveling at 40 km per hour, correct? This train is overtaking us and actually it is going at a speed of 60 km per hour. But when you see from this train, you will feel that this train is traveling only at 20 km per hour. So, if both the trains are traveling in the same direction, or when both the objects are traveling in the same direction, or one object is overtaking another object, I can say that the relative speed is nothing but the difference between the speeds of the objects, correct? Is this clear? Are you all able to relate to the train example? Right, all of us would have gone through this. Yes, similarly, now let us say there are two trains again, right? Train 1 and train 2, two trains traveling in the opposite direction, okay? This train 2 is going in this direction, train 1 is going in this direction. So basically both the trains are crossing each other, okay? Now this train is traveling at 60 kilometers per hour, this train is traveling at 40 kilometers per hour. Right, but in turn, when you look at, you are sitting in this train, train 1, this is train 2, and when you are sitting in train 1 and looking at train 2, you actually feel that the train 2 is traveling at a speed of 100 kilometers per hour. Again, that is because of relative speed, right? I hope it's clear what I explained. Is this concept clear to you? Do you want me to explain it once again? Is this concept clear, guys? Any doubts? When two objects are traveling in the same direction, the net speed is the difference between their speeds, and when two objects are traveling in the opposite direction, the net speed is the sum of their speeds. Yes, it is clear? Great. Syed says it's clear. Excellent. So, let's move on. Now let's, no. Aman says no. Okay. Okay, Aman, I'll explain it once again. See, okay, Suraj says clear. Okay, I'll explain briefly in 1 second for Aman. Yeah, all of you. So, see, there are two trains. Okay, see how I explained relative speed was, there are two trains. If both the trains are traveling in the same direction and one train, that is, let us say here T2 is trying to overtake T1, when you are looking at train T2 from T1, what you feel is this train T2 is traveling only at 20 km per hour and you feel you are stationary. This is because of relative speed. Okay. Now what is, It's clear. Chandu says it's clear, right? So similarly, if the trains are traveling in the opposite direction, that is one train is traveling with 60 kilometers per hour and other train is traveling with at 40 kilometers per hour. When you sit in one train and look at the other train, you feel that that train is going at 100 kilometers per hour. Again, that is because of relative speed coming into effect. Okay. Okay. Now let's move on to the questions to be solved from this session. So let us look at the first question. See, this is a, explain again. Okay, see Sinduri, just keep in mind that if both the objects are traveling in the same direction, the net speed of the object, like the net speed is considered as the difference between the speeds of the object. If both the objects are traveling in the opposite direction, the net speed is nothing but the sum of the speeds of the object. Okay? Okay. Now, let's move on to the questions from this session. The first question that we are going to solve is a question on it is the very famous thief and policeman problem, right? This question comes in a lot of placement exams. Okay, now let us look at this question. A thief is stopped by a policeman from a distance of 400 meters. When the policeman starts to chase, the thief also starts running. Assuming the speed of the thief as 10 kilometers per hour and that of the policeman as 15 kilometers per hour, how far the thief would have run before he is overtaken, right? Okay, so let us solve this question. See, for whoever you guys didn't understand the explanation, I will be solving the problems from this now, right? So you can, if you listen to it again, you will have a better understanding, okay? So there is a thief, right? There is a thief and there is a policeman, okay? The policeman is seeing the thief 400 meters at a distance of 400 meters, right? Now the policeman is starting to chase the thief and the thief is running with a speed of 10 kilometers per hour and the policeman is running at a speed of 15 kilometers per hour, correct? Now at some point, okay, because the policeman is running faster at some point, right, he is going to catch the thief. So this is where both the policeman and the thief are going to come and the police is going to catch the thief or overtake him, okay. Now they have asked, what is this distance travelled by the thief in this much time before the policeman catches him? Okay, so how do we do this question? Again, there are two objects, right? Two objects, both are moving in the same direction, right? This one is traveling at 15 kilometers per hour and this one is traveling at 10 kilometers per hour. Now, since the speed is given in kilometers per hour, first let us try to use the unit kilometers, kilometer per hour and hours. Okay, for now we will solve like that. But you see, when you come to the answer, you have to convert it into meters because here it is given in meters. The options are given in terms of meters. For now, we will take everything in terms of kilometers and kilometers per hour and in the end, we will try to convert it back to meters because why I am doing this is because it is easier to calculate. See, as I said, whenever you get a question from time, speed and distance, look at the units and see to it that the units are uniform for time, speed and distance. Okay. Here, I am doing it this way for easiness, right? For easiness of calculation. Okay. Now, what is given? Thief. The distance between the policeman and the thief is 400 meters. How much is 400 meters? 400 meters is nothing but 4 by 10 kilometers. Am I correct? 400 meters is 400 by 1000 kilometers or that is nothing but 4 by 10 kilometers. Okay. Now, here what is the relative speed between the policeman and the thief? See, the relative speed between the policeman and the thief is nothing but 15 minus 10. Why? Because both of them are traveling in the same direction. So the net speed is the difference between the speeds of both the people, that is 5 kilometers per hour. This is the relative speed between the policeman and the thief. Now, at what time will the policeman catch the thief? The policeman will catch the thief at what time? Nothing but 400. That is 400 meters divided by the speed, correct? Here we have to take into consideration the relative speed. So 400 meters is nothing but 4 by 10 kilometers. So 4 by 10 divided by 5, correct? This is the time when the policeman will catch the thief, correct? In this much time, the policeman will catch the thief, or I can say that in 4 by 50 hours, the policeman is going to catch the thief. Is it clear? How do I do it? See, time is nothing but distance by speed, but here what happens? Here it is, we have to take into consideration the relative speed. Since both the objects are traveling in the same direction, we are subtracting the speeds, correct? To get the relative speed. So the time taken to catch the thief is nothing but the distance divided by the relative speed, or that is equal to 4 by 50 hours. Clear? I hope it's clear. So what is, now in this much time the policeman is catching the thief. Okay, and in this 4 by 50 hours, what is happening? The thief is running some distance x, correct? And how much will be the distance that the thief would have traveled? It is again nothing but the distance traveled by the thief is nothing but equal to the time for which he travels into the speed at which he travels, correct? So what is the time for which he has traveled? He has traveled for 4 by 50 hours with a speed of 10 kilometers per hour, correct? Or I can say that he has traveled 4 by 5 kilometers in that time. Now what is 4 by 5 kilometers? See, we know 1 kilometers is equal to 1000 meters, correct? So this is nothing but 4 by 5 into 1000, correct? 4 by 5 into 1000, or that is equal to 1000 by 5 is 200, 200 into 4 is equal to 800. So he travels 800 meters. Correct? I hope it's clear. So answer for the question is option A. Any doubts in this question, in the way we did? Kovendan Sinduri, just keep in mind that when two objects are traveling in the same direction, you have to subtract their speeds, right? Similarly, when two objects are traveling in the opposite direction, add their speeds. Now, why am I saying this? Subtract speed, add speed. So just don't by heart it saying that if two objects are traveling the same direction, subtract the speed. No, it's not like that. Just think of the train case, right? When we are sitting in a train, what happens? So if you relate it to that, the concept will be clear to you. Okay? So is this clear? Shall we move on to the next question? Okay, let's move on to the next question. Again, the next question is again from the topic of trains. One train runs from A to B at 105 miles per hour. The other runs from B to A at 85 miles per hour. How far apart were the two trains 30 minutes prior to their crossing? So again, the concept of relative speed to be used. Now, can you guys try to solve this question for me and give me the answer? And then I'll go about solving the question. Anybody got the answer for the next question? This question is also of the similar type of the previous question that we solved. Okay, Sai says 95 miles. Okay, let us solve this question. So one of you have given me an answer. Sai, we'll see if your answer is correct when I solve it. Okay, one train runs from A to B, correct? There are 2 points A and B, which is at a distance of 105 miles, correct? 105 miles. Now, oh sorry, it's not the miles, it's miles per hour. Sorry, I made a mistake. Okay, let us start. See, there are 2 points A and B, correct? Now there is one train which travels from A to B at a speed of 105 miles per hour, correct? And there is another train which starts from B and moving towards A at a speed of 85 miles per hour, correct? Now, how far apart were the two trains 30 minutes prior to the crossing, correct? Now, what is 30 minutes? See, 30 minutes is nothing but in terms of hours, correct? Here everything is in terms of miles and hours. So, we have to convert everything in the same unit. So, I can say 30 minutes is equal to 30 divided by 60, or that is equal to half an hour, correct? Now, in this half an hour, what will be the distance covered by the two trains? If we find out that, we will get the answer, correct? The question is how far apart were the two trains 30 minutes prior to crossing. So, if I find out in this 30 minutes, what is the distance that both the trains will travel, I will get the answer, correct? So, what is the distance that both the trains will travel in this 30 minutes? See, distance we know is equal to speed into the time, correct? But here we have two objects traveling in the opposite direction, so the net speed is considered as the relative speed between the two objects, or that is equal to the sum of the speeds of the two objects, correct? So, this is equal to what? Distance, that is the speed, the net speed is equal to relative speed, or the net speed is equal to 105 plus 85, correct? Or that is equal to 190. Correct, this is the relative speed, 190 kilometers per hour it is traveling. For how long is it traveling with this speed? It is traveling for half an hour. So, the distance that it will cover will be equal to 190 into half an hour, that is 1 by 2, or that is equal to 95 miles. Correct, very easy question, no? Correct. So, answer for this question is 95. Sai, you were right. Lot of you have got the correct answer. Afsar, it is 95 miles. I hope it is clear. 190 by 2. 90 into 2 is 180. So, 190 divided by 2 is 95. Is it clear? Shall I move on to the next question? The question was how far apart were the two trains 30 minutes prior to crossing. So, I have just found out what is the distance travelled by the two trains in 30 minutes, correct? They are moving towards each other. So, what distance will they cover? That is what I found. So, we get the answer. I hope it is clear. A lot of you have got the correct answer. So, let us move on to the next question. So, this is the famous bird train problem. Okay. Again, this question has been previously asked in a lot of recruitment drives. Yeah. Afsar got it? Good, Afsar. So, the question is this. Two trains 150 miles apart are travelling towards each other along the same track. The first train goes at 60 miles per hour. The second train rushes along at 90 miles per hour. A fly is hovering just above the nose of the first train. It buzzes from the first train to the second train, turns around immediately, flies back to the first train and turns around again. It goes on flying back and forth between the two trains until they collide. If the fly's speed is 120 miles per hour, how far will it travel? So, how do we solve this? Again, you guys try and give me an answer, then I will solve the question for you. Again, if you know the concept of relative speed, solving this question becomes very easy. Right? These are actual questions that have been asked in recruitment drives. So, see, if you understand the concept, nothing like it. Very easy to solve. What would be the answer for this question? Okay, Asar Sheikh in the chat has asked me, see I was giving you an explanation about the trains, right? If there are two trains traveling in the same direction and you are sitting in the slower train and you are viewing the faster train, right? When the slower train is traveling at 40 kilometers per hour and the faster train is traveling at 60 kilometers per hour, I told you that we will feel that the second train is traveling or the faster train is traveling at a speed of 20 kilometers per hour only, correct? Now, the question that Azhar asked me was, what if I am sitting on the faster train? Okay, so how it works is, see, if I am sitting on the faster train again, I will feel that I am traveling only at 20 kilometers per hour and the other train is stationary. Azhar, I hope it's clear. I hope I answered your question. Okay, in the meantime, a lot of you have given me answers. A lot of you says 120 miles. Okay, let us solve this question. So there are two trains, 150 miles apart, traveling towards each other. There are two trains. The distance between the two trains is 150 miles. Okay, 150 miles. So this is train 1 and this is train 2. And there is a bird. Okay, this is traveling at 60 kilometers per hour. And this is, not kilometers, miles per hour. See, always miles per hour, and this is traveling at 90 miles per hour. Okay, always look at the units, right? Then there is a fly which starts from the first train, okay, and it is going towards the second train. Then what it does, it goes back from the second train to the first train to second train till both the trains meet, right? It is keeping on moving from one train to another. That is what is given in the question. And at what speed is the fly traveling? The fly is traveling at a speed of 120 miles per hour. So first, let us see at what time will these two trains collide. Let us find out that. See, there is a distance of 150 miles between the two trains and they are traveling with speeds of 60 miles per hour and 90 miles per hour. So when will the two trains meet? How long will the two trains take to meet? 150 divided by the relative speed, correct? Two objects traveling in the opposite direction, the relative speed is nothing but 150 divided by 90 plus 60, or that is equal to 150 by 150, that is equal to 1 hour. So both the trains will meet in 1 hour's time. Okay. Now in this 1 hour, what will be the distance that is travelled by the bird? Since the bird is travelling at a speed of 120 miles per hour, in 1 hour the bird will cover how many miles? It will cover 120 miles. See, it is given in the question that it is travelling at a speed of 120 miles per hour, and here it is given that both the trains are meeting in 1 hour. So in that time, the bird can travel only 120 miles. So before both the trains meet, the bird would have travelled 120 miles to and forth. Okay, I hope it's clear. So answer for this question is option C. I find that a lot of you have got the correct answer. Good. Okay, now let's move on to the next question for today's session. Now the next question is from boats and streams. Now before solving this question from boats and streams, let me talk about the concept of boats and streams again here, okay? Now if you get a problem from cars or trains, you can do, right? Because we found out how to calculate the relative speed, right? We also explained it with the help of a train example, right? To understand it better. Now let us think of a river, okay? There is a river, yeah? The river is flowing in this direction, okay? This is the flow of the river, and there is a boat, okay? The boat is going in this direction. Correct? There is a boat that is traveling in the opposite direction. Now, tell me, okay, let us assume that this river is traveling at a speed of, the flow of current is at a speed of 2 kilometers per hour. Correct? Now, this boat is going on the opposite direction, right? With a speed of, let's say, 5 kilometers per hour. Correct? That is this actual speed of the boat. Now, when you take into consideration the relative speed, do you add here or do you subtract here? See, the current is flowing in this direction, correct? But the boat is going in the opposite direction. But here, when it comes to boats and streams, when the boat or the person is moving in the opposite direction compared to the water current, you should subtract the speeds, okay? So here, what is the net speed of the boat or the relative speed of the boat with respect to the water flow? It is actually 5 minus 2, or that is equal to 3 kilometers per hour. This is the relative speed here. Or if the boat was traveling in the same direction, okay, if the boat was traveling in the same direction as the water current, then the relative speed would have been 5 plus 2, or that is equal to 7 kilometers per hour. Okay. Now why is it opposite for boats and streams? For train problems, what happened for train problems? It is reversed to previous. Yes, somebody says, Kalyan Kumar says it's reversed to previous. Why is it reversed to previous? See, again, think of it practically. Now you are traveling in a boat, you have to push against the current of the water to go up, correct? So when you go in the opposite direction, you are going against the water current. So you are subtracting the speeds, correct? Similarly, when you go along with the water current, you will go further forward, correct? So your speed in net increases. So you are adding. Now if this thing is clear to you in your mind, it will become easy to solve the question. Now let's solve the question. In the meantime, I see that a lot of you have got the answer. Let's see if it's correct. Okay, so what is given? A man swims. Okay, a man can swim. So there is a water current. So I am assuming that the water current is flowing in this direction. Okay, there is a man swimming. So a man can swim downstream at a rate of 3 kilometers per hour. Correct? So there is the speed of the water and there is a man swimming. Correct? He is also swimming in this direction. So the speed of the man. Correct? He is traveling at a rate of 3 kilometers per hour he can do, and upstream at a rate of 2 kilometers per hour. So what does this 3 kilometer represent? This is his net speed, correct? So if I am assuming that the speed of the water is SW and the speed of the man is SM, correct? So downstream means both of them are traveling in the same direction, so will actually come faster, correct? So the net speed is SW plus SM and this is equal to 3, correct? Similarly, now if he is going upstream, correct, he has to go against the water current, so his net speed will reduce, correct? So SW minus SM, this is equal to 2. Now what have they asked? How long will it take him to swim 7.5 kilometers in still water? So we have to assume that there is no water current, correct? SW is not there. So what time will he take to cover 7.5 kilometers? So basically we have to find the speed of the man, correct? First is speed. So what is the speed of the man? Let me subtract these two equations. What do I get? I get 2 SM is equal to 1, correct? What do I get? 2 SM is equal to 1. Okay, sorry, I made a small mistake here. See, it is actually SM minus SW, correct? Sorry, let me rewrite it. I wrote this equation in reverse. See, because the speed of the man has to be definitely be more than the speed of the water current, correct? Then only he can swim across, correct? So this is SM minus SW, that is equal to 2. Is it correct now? Yeah. So now I have to find SM, correct? So I am subtracting the two equations. So what do I get? I am adding the two equations. So what do I get? I get 2 SM is equal to 5, or I can say SM is equal to 5 by 2. So this is the speed of the man, actual speed of the man. So in still water, this is the speed with which he will swim. Okay, now what is the time taken to travel a distance of 7.5 kilometers in still water? It is nothing but 7.5 divided by 55 by 2, correct? So what is 7.5? 7.5 is nothing but 15 by 2, correct? So 15 by 2 divided by 5 by 2, or 15 by 2 divided by 5 by 2 is 15 by 5, or that is equal to 3. So answer for this question is 3 hours. Okay, so somebody says repeat. I'll repeat it again once for you. See, a man can swim downstream at a rate of 3 kilometers per hour. So at a rate of 3, see, he is covering 3 kilometers per hour when he is swimming downstream. So somebody says water velocity is not given. See, you have to assume that it is given to you, right? See, what is this 3 kilometer per hour represent? It represents the speed, the net speed of the man, correct? So what is the net speed? It is nothing but the speed of the water plus the speed of the man, and that is equal to 3. Now when he is going upstream, again he is able to cover 2 kilometers per hour. So the speed of the man minus the speed of the water current is equal to 2, correct? Why am I putting, see, if you see in the beginning I accidentally wrote SW minus SM. It's not that way. It is SM minus SW because the speed of the man is definitely more than the speed of the water current. So when I am equating these two equations, I get that SM is equal to 5 by 2 kilometers per hour. So in this speed, this is the actual speed of the man. So if the water is still, the only speed will be the speed of the man. So 7.5 kilometers, how long will he take to cover? He will cover it in 3 hours. Correct? So answer for this question is option C. Is it clear? A lot of you guys are saying the answer is 1.5. Is it clear now how it is 3 hours? Okay, Shaktivel says yes. Okay, so let's move on to the next question for today's session. So the next question is this. The distance between two stations X and Y is 600 kilometers. A train starts at 4:15 p.m. from X and moves towards Y at an average speed of 40 kilometers per hour. Another train starts from Y at 5 p.m. and moves towards X at an average speed of 80 kilometers per hour. How far from station X will the two trains meet? So how do we solve this? Okay, a lot of you have replied saying it's clear now. Excellent. So try to solve this question. So what is given in the question, let me just write down the information by the time you answer me. So there are two stations, X and Y, correct? The distance between the two stations is 600 kilometers. There is a train, let us assume that it is train X, okay? Train X starts from this point at 4:15 p.m., okay? There is another train which starts from Y at 5 p.m. Now the speed of this train is 40 kilometers per hour. And the speed of this train is 80 kilometers per hour. Correct? How far from station X will both the trains meet? So where do they meet? This is what is asked. Now one information that is given here is that this train is traveling at this train started traveling at 4:15 p.m. and this is starting only at 5 p.m. Okay. Any answers for this question or shall I start solving? Okay, I guess I'll solve. Any answers? I'll wait for one more minute to get any answer or I'll solve. Okay, great. Somebody says 180 kilometers. Let's see. Sai says 180 kilometers. Yes, you can definitely try it without pen. Kalyan Kumar, give me the answer without a pen. Good. Good that you're trying without a pen. Okay, I will solve it. Okay, Suraj didn't get the answer. He says solve it, ma'am. Okay. So, okay, so now let us take train X. Train X is starting at 4:15 p.m. Okay, so it is traveling for 45 minutes extra more than the train Y. So in this 45 minutes, what will be the distance that will be traveled by train X? See, 45 minutes you should convert it into hours because now here in the problem everything is in terms of hours and kilometers, correct? So 45 minutes is nothing but 45 by 60 or that is equal to 3/4 hours, correct? So in this 3/4 hours, how much does the train X travel? The train X will travel 3/4 into 40, correct? This will be the distance that will be traveled by train X in this 3/4 hours, correct? Because distance traveled is nothing but equal to speed into time. So 3/4 into 40, that is equal to 30 kilometers. So in 45 minutes, this train would have traveled 30 kilometers. So it will be somewhere here, correct? So train X is going to be here, train Y is going to be here at 5 o'clock. Now, what is the distance between them now? The distance between them now is 570 kilometers. So these trains have to, before they meet, they have to travel this 570 kilometers. This is traveling at a speed of 40 kilometers per hour and this is traveling at a speed of 80 kilometers per hour. So when will they cover this, when will they meet? So they will meet at the time at which both the trains meet. That is equal to from this point to this point. Okay, I am considering this 570 kilometers distance now. In what time will they meet? 570 divided by 40 plus 80. Here two objects are traveling in the opposite direction, so the net speed is nothing but the sum of the speeds of the two objects. So this is equal to 570 divided by 120. So in this many hours from 5 o'clock both these trains will meet. Now the question is, what is this distance, right? You have to find out this distance. This is the question. Now how do I find out this distance? Okay, from 5 o'clock till this point where they meet, what is the distance that is travelled by this train X? This distance we can find out, right? How do I find out? See, the train X is travelling for 570 by 120 hours. So what will be the distance that is covered by the train X in this time? It is nothing but 570 divided by 120 into the speed of the train, correct? The speed of the train is 40. See, don't sit and simplify here. Use it as such. This 570 by 120, whatever is given, just keep it there as such, correct? So you can cancel. Again this is 3, again 570 divided by 3, correct? Or that is equal to 570 by 3 is again easy to do, 190, correct? 190 is 570 divided by 3. So I can say that the distance that is travelled by train X, correct, from 5 p.m. till when both the trains meet is equal to 190. Now the question is, what is this distance, correct? This is the question. Now what is this distance? It is nothing but this 190 plus this 30, correct? 190 plus 30. This 30 kilometers is nothing but the distance that was travelled by the train X from 4:15 to 5 p.m. So the total distance is nothing but 190 plus 30, or that is equal to 220. That is the distance from point X till when both the trains meet. So answer for this question is option D. Is it clear? Kalyan Kumar, you got the answer? Excellent. So I hope it's clear. See, when such values come 570 by 120, just don't solve it then and there. Might be you will be able to simplify it later, right? So you can save time on, ma'am, why you are multiplying 570 by 120, where? Into 40, correct? See, this why I am multiplying is, here from, let us say from 5 o'clock, okay, train X is starting from this point and it is meeting train Y here. Now the time taken to meet is 570 by 120 hours. So I am actually finding out the distance that is travelled by this train X from this point till this point. How do I calculate it? To go from this point to this point, it is taking 570 by 120 hours and it is travelling with a speed of 40 kilometers per hour. So what is this distance? It is nothing but the product of the speed and the time, correct? That is how I got 190. Chandu, is it clear? Got it. Okay, excellent. Okay, so with this we come to an end of the problems that has been taken for this session. So I hope the problems that we solved today was clear to all of you and the concept of relative speed is clear. See, other than this concept of relative speed, you can expect problems from average speed, correct, and variable speed problems from time and distance. And again, in relative speed itself, you will have questions based on trains, correct, where you will have to take into consideration the length of the trains. These are the other types of questions that you can expect from this topic, time, speed and distance, right? So any doubts that you guys have in this particular problems that we solved today, please feel free to ask. Any doubts? So as I said, other than the problems that we solved today, check out problems on trains where you have to consider length of the train. That is also from relative speed. Yes. See, we generally have live sessions happening currently every Friday at 6 p.m. right? You can check out our website and our portal, like your YouTube channel, to know the details about the live session, right? Generally it is 6 o'clock, as of now it is 6 o'clock on Fridays, but you can check out our portal to be updated, our YouTube channel I mean. So, any more doubts? So, Suraj says thank you. Great, Suraj. Hope the session was useful for you. For IT, we don't have currently sessions happening on Wednesday. The current schedule is, it happens on Friday evening at 6 o'clock. You can check in our YouTube channel. The details of the session will be put up one day prior to the session in our YouTube channel. If you are subscribed to our channel, you will also get a mail from us. Okay, so I hope everything was clear for you. I don't see any doubts, and really happy that the session was useful for you guys, right? All the very best with your preparations, and I'll see you in the next session. So this is Gayatri signing off. It's bye from me now.